Okay, in this video, we're going to go over the electrical energy analysis for an example project. So in this example, this is a plan of a restaurant bar, and it has a cellar, a first floor, a second floor, and a roof. So the second floor is has an area right here, which is a double high ceiling. So basically that means that somebody can look down and they could see the first floor through this space. So that would basically line up somewhere above this area here. So anyone that's standing here can look up and see the ceiling of the second floor. So this is open to below, this X, and this is a terrace, so they can just walk out, and this will be an outdoor area. So you have these outdoor receptacles here. So for the energy code, we have to look at the lighting plan, because a majority of the requirements from the energy code deals with the lighting system. So in the cellar, we have these two lights and a switch, and the switch, you can see, has this gray line that connects the lights that are connected to that switch. And same with this, you can see this is a kitchen area, and it has three switches controlling three separate lighting groups, as you can see. And this is the double high ceiling, and this is the restaurant bar area, and basically also the dining area as well, right here. So if you look on the power plans, you could see the furniture. So you could see this is the dining area included here. So this is the bar. You have some chairs at the bar. And this is a storage space. So the second floor, this space, as well as this room, is all part of storage. Before you begin with the energy analysis, you have to first determine whether your space requires the energy analysis to begin with. So you have to check in New York City, the buildings that are in a historic district are exempt from the energy code. So you would have to first determine by looking at the landmark map in New York City whether your building falls within that historic district. And if it is, the energy code would not apply for your project. In this example, let's say it does apply since it is not in a historic district. We're going to go ahead and start the energy analysis. So I'm going to first talk about the power allowance. So the energy code requires the total lighting cannot exceed the power allowance that's calculated using the energy code. So we're going to use the building area method, which is the simplified method compared to the space by space method, to calculate the total interior lighting power allowance. So we have to pick the area type that is closest to our project. So looking through this list, you can see right here, dining, bar, lounge, leisure. This one also is dining, but it's cafeteria, fast food. This one's family dining. So it looks like this one is the closest to our project. Dining, bar, lounge, leisure area. And you can see on this side it's 0.69 watts per square feet. So we're going to use that over here. So for the table, this is the correct table, 405321. 405321, and building area type would be dining. I'll add a little more detail and say bar, lounge, leisure. And you can just move this to the side so everything fits. And we have to get the total floor area. So what I would do is these zones are already created that shows the circuiting of all the lights in that zone. So I could just get the area through that. So I'll click this, right click, go to properties, and you can see down here it's 297. I'll just round that to 300. And I will basically add up all the floor areas. So this zone here is 825. And we also have to get the cellar, which is 130. And also the second floor, which is 573. So the total of that is 1828. So that will go right here, 1828. Now we're gonna list all the fixtures down here. So in this list, we're gonna list all these fixtures. But before we do that, I'm gonna go in here and update this. So the total watts for exterior area, we're gonna cover this later. We're just focusing on the interior lights for now. So for the interior lights, the allowed interior lighting for area type watts per square feet, we basically had it right here. For bar leisure, it was 0.69 watts per square feet. So we'll use 0.69 right here. And the supporting documentation for all of this would be on the electrical lighting plans. So now we have to go down this list right here and add all the lighting fixtures. So the fixture tag is basically this right here. The P3, S1 are all fixture tags. So if you look on the plans, the P3, the symbol and the ID tag would be located right here. And same with the S2s, as well as all the other fixtures here. So we'll just make a list starting from the top. So this one is P3. So the fixture tag would just be P3. And fixture type, we'll just call it recessed light. I'll just call it recessed. And the quantity is listed here. Sometimes the lighting schedule would not have the quantity, so you would have to count the quantity from the plans. So here it's 19, so we'll just fill that out right here, 19. And I'll copy this by making a window, and you can actually drag it down this way. Another way is you can just Control C and you could just paste it just like that. So two different ways you can do that. I'm just gonna go like this and I'll just drag it down and I'll fill in the rest. So this one is S1. And that one is surface. And the quantity is 7. Alright, so I went ahead and I added all the different fixture types from this schedule here, along with quantity and the wattage that were listed in this fixture schedule here. All right here for the quantity, the watts, and the fixture tag. For the LED strip, it's not an actual quantity in terms of the quantity of the fixture, but for the LED strip, the quantity is in terms of feet. So the wattage is also based on per foot. So it's 2 watts per foot. So in this case, I would put 2 watts under this column here, and then the quantity would be actually in feet. So when you multiply these two, you would get the total watts. If you look at this, you could see the formula that's in this cell. It's going to be G3. So right here, you could see the G, and then the 3 would be right here, times H3, which is this one. So it's the quantity times the watt would be the total installed watts for that fixture tag. So I can just click this and then drag the formula down, and it should update the row. So in this case, it's actually G4 times H4. So it's this row, and the next one should be row 5. Okay, so all of this automatically calculates the total watts for each fixture type. So now we're done with this part right here, the interior lighting power. Now we have to calculate the exterior lighting power. Okay, so I basically modified the table just a bit so the formulas are basically updated. So all this total interior watts here would basically be calculated right here, and the formula would be sum, and then you take I3, which is this right here, I3, so it's this cell, up to I9, as you can see there. So this would be I9 right here. So it would automatically sum up everything here, and then the grand total allowed watts, this is the power allowance from the energy code, is the sum of anything here. So here, this column is for the interior lighting power based on the density right here. So this would be M3, which is this number, multiplied by D3, which is the interior floor area square feet. So this times this will give you the total wattage that is allowed. So this number basically goes in here because this number equals M13, which is basically this cell right here. So basically M13. So you could see that the total wattage of the lights is less than the total allowed by the energy code right here, which is 1,261, and we have less than that at about 700 watts. So the interior lights comply with the energy code. Now we have to look at the exterior lighting power, and to do that we have to look at this table right here for building exterior. And if you look here, we have to first determine what the lighting zone is. And in this case, it's part of a high activity commercial district, so it'll be in lighting zone number 4. So with that, we have a base allowance of 900 watts. So that 900 watts is basically listed right here. And this value is then placed here. I just made it equal to this cell, which is K3. And we also have something for a walkway. So if you look back at this table, we don't have any uncovered parking areas, but we do have this walkway right here. And it's going to be less than 10 feet wide. So this is basically the sidewalk in front of the store. And for zone 4, we have to follow 0.7 watts per linear foot. So I put that value right here, 0.7 watts per foot. And this would basically be the L3, which is this field right here, multiplied by D17, which is basically put right here. So that will give you the total wattage allowed for that walkway. And we have to look at the chart to see if we have more allowances that we can add. So looking at the other areas, we have a building entrance and exit, so we can apply this section right here. But we don't have sales canopies or outdoor sales areas. And a canopy is basically like this. This is a canopy that kind of sticks out past the exterior wall to basically protect from rain and things like that. So we don't have this canopy. We do have this pedestrian entrance though, and it's gonna be 20 watts per linear foot of opening. So we're gonna have to add, first of all, another column to include that. So to do that, you click this, you could click the top, right click, and we can add a column to the right. And I'm just gonna copy this. And for that, it's gonna be pedestrian, so it's gonna be the pedestrian entrance, and it's gonna be 20 watts per foot. So right here, I'm gonna say for allowed for exterior pedestrian entrance, and it was 20 watts per foot. So right here it's going to be 20. Okay, and we're going to add that distance right here. So I'm going to go here and paste it here, and I'll just type in entrance opening, and we need to get the entrance opening distance, so we could type in DI to get a distance measurement from this point to this point, and it's 5 foot 1 inches. So we'll just call it let's say 5.1 feet, and then we need to add that calculation down here. So it's going to be this number times this number here. So it's going to be M3 times M3 times D18. So right here we can go D18, and that'll basically multiply the 20 by 5.1, and you get this 102. Now we have to fill in this section right here for the exterior lights. So the fixture tag for the exterior light, there's only one, it's the P4. So we're gonna take the P4, and there's 3 of them. So P4 is the wall sconce, so we'll put that right here. P4 wall sconce, and we had 3 of those, and the wattage for the P4 is right here, and it's 15. So we can go here and type in 15, and that's the watts. And looking at the plans, the P4 fixture is not inside the building, so the P4 is not an interior light. This is a P3, and we don't have any P4s here, right? They're all P3s. So I have to go back to this table and remove the P4 from the interior light. So I can just delete this entire row. So I'm just checking this row to see if there's any other data. There isn't, so I could basically remove this row right here. So I can just click this, right click, and then you could click delete row, and it'll take that P4 row out of here, and all the calculations will basically readjust. So if you click this, you can see that it goes to I8, which is basically this row right here, which is the last row. So all of these automatically adjusted here. And we can remove this fixture type here, since the only fixture at the exterior is this P4. So this one we do not want to remove the row, since we have some data that's being used. So I'll just make a window highlighting everything that I want deleted, and then hit delete. And the grand total installed watts for the exterior, just confirm that it's adding up only the exterior fixtures. So it's going from I16 to I17. So it's only calculating the exterior fixtures in this cell right here. And all the interior fixtures are calculated right here. So the total allowed power for the exterior lights would be the sum of these 3 here. Okay, so it's the 900 up here, and from these 2 numbers here, it was calculated to be 16 and 102. So the total allowed would be the sum of all 3 of these. So we have to make sure that the formula is correct. So it's K, L, and M all in row 21. So K, L, we're missing M, so I'll add that here. And that's the total. So you can do a check, and basically the total installed watts for the exterior lights is less than the total allowed by the energy code. So we basically comply for both the interior lights and the exterior lights. Okay, now we're going to go over the controls that are required by the energy code in terms of the areas that require the occupancy sensor, time clocks, daylight sensors, and any type of exterior controls. So we'll start with the interior lights on the second floor. And we have an accessory storage space here, storage space here, and this is the double high ceiling to the first floor. So to determine what type of controls we need, we have to go back to the energy code. And if we look here, we could see that the occupancy sensors are required in the following spaces here. So for storage rooms, it's under that list. So in this case, we would need an occupancy sensor. So the occupancy sensor for small rooms such as this, I would basically just add a wall switch that comes with the occupancy sensor built into the switch. We have to go to this symbol list and find a symbol that represents a occupancy sensor switch. And if I look here, we have one OS right here. It says occupancy sensor wall switch DW-100 by Wattstopper. It's a dual technology type, which means it has passive infrared as well as the ultrasonic. 120, 277 volt, or approved equal. So we are giving the installer a choice to use this or something similar to this one. So we're going to use this for that area. So we need to copy this. And place it right here to indicate that this is a occupancy sensor switch. For this, it's for a larger area. So in these areas, it's better to use a ceiling mounted occupancy sensor. So we're going to go in here and find a symbol for a ceiling mounted occupancy switch. So these are the symbols. So this is the one that we'll be using. So I'll just copy this and place it right here. And the occupancy sensors, you should give it a range or coverage area about 15 by 15. So it's going to be 15 on either side. So basically it'll be 15 this way, as well as this way, and this way. So